Okay, so this video is going to be about reviewing the storm drain system, the stormwater pipe system. Different municipalities have different design standards for design storms for the storm drain system. The most common is for the 10-year storm, but some also require the 25 or even the 50-year storm. For the first thing you have to do is request a hydroflow rainfall report if it's not already provided. As with all my videos, or all the hydraulic and hydrology videos, we'll be looking at hydroflow. And in the hydroflow rainfall report, there'll be a section that shows the different rainfall depths, and you just need to make sure those are correct. So after reviewing the rainfall depths, the next thing to check out is the storm sewer summary report. And these line IDs should correlate to the IDs that are used in the engineering drawings. And then what I typically do is just I spot check that the line size correlates to the line ID that's shown in the engineering drawings. If there are hundreds of pipes for a site, it's not worth your time to check all of them. A lot of times this is copy and paste over into the plans, so little room for error for the engineer. But I will spot check 20% or so. So if there's 200 pipes, I'll try to check 20 to 30 at least, and make sure that the pipe diameters are correct and that the invert elevations that are shown in the model match what is shown in the plans. Okay, so now to review that the pipe system actually has the capacity to carry the design storm, you'll have to ask the engineer to provide the storm sewer profiles. This is just a print option in hydroflow. This isn't a lot of information that the engineer has to, it's not a bunch of additional information he has to input into the model. This information will already be in the model, so getting this is very simple. It's just a print option again for storm sewer profiles, and it makes it incredibly easy to review the storm drain system to determine if there's any surcharging from the system. Now, the first thing you have to decide before I show you how to review the pipe system is what you define as surcharging. One option is that there's flow escaping from the system, so it's coming up out of the pipe, up out of the inlet, and running over into the ground. The other way you can define surcharging or the capacity of the pipe is if the hydraulic grade line gets above the crown of the pipe. Because when you have this, it can cause some issues, some pressurization issues, surcharging issues, some potential vortex issues. So when I'm doing a review, I always ask the municipality how they define surcharging or how they define the capacity of their design storm, if it's that the hydraulic grade line gets above the ground elevation or does it get above the crown of the pipe. So that's something to discuss internally. Now, how do you review that? After you request the storm sewer profiles, which again is very easy for the engineer to provide, you'll simply look and see. So the red line represents the hydraulic grade line. So if this red line gets above the green line, which is the ground elevation, then you have water coming up out of the pipe system, out of the inlet, and spilling over onto the ground. Similarly, if the red line gets over the blue line, then your hydraulic grade line is getting above the crown of the pipe, and then you could also, potentially have some of those issues. So you're either checking that the red line stays below the blue line or the green line, however you define it. And then there'll be several pages depending on how many pipes there are in that system, and then you can just easily scroll through them quickly and check each page will have 3 or 4 sections of pipe, and a very quick and efficient way to review the storm drain system. Okay, so the final thing I want to say about the storm drain design is finding your critical points, your failure points, and you do that by look for sags, and this is mostly applicable to subdivisions and larger industrial developments. And the way you find these with subdivisions along roads, and what the goal here is, you're assuming that the storm drain system has failed. The crushed pipe, whatever has occurred, or the system is backed up, and water is just flowing down the road, down the curb, and going to the low points. So you're looking for the sags, and to do that, you just follow the contours on the road. They point which direction flow's going. So if you look where my hand is at here at the 758 road contour, see how it's pointing? So water is flowing down this way. Versus, over here on this road, if you're at my hand, follow my hand here, all these are pointing down the road. So water is flowing this way when the system isn't working. Then it would go down this road and get to these inlets. And as you can see here, this road contour is pointing this direction, so water is flowing down this way. So what you want to do is find two road contours that point at each other. This one points this way, this one points this way. Go to this inlet. So there you have a sag. That's a critical point where if the storm drain system has failed, a lot of water is going to get to this area. So then what happens? Water starts to pull up along the road. Okay, because these inlets are only designed to get a small little portion of area, but if the system's failed, they're getting many acres coming to this point. So water's going to pond up here, get into the individual lot swell, and then go into this inlet, likely overwhelm this inlet, and then hopefully overtop the berm here, which it shows it flowing down into the pond, and it'll likely cause a lot of erosion. So my biggest fear here is that if this lot or these section of lots puts up a retaining wall and then blocking this flow because this inlet's within their property, that could create a really bad situation for some flooding. So that's one of the most important things that you want to look for. Look for sag points along the roads, and then what happens at those inlets. Okay, and then you want to request or recommend that the engineer, so for this specific instance, I would request that the engineer put in an overflow swell between these lots with an easement. And then in the easement, you clearly have that there can be no walls or fences that would obstruct flow. That'd be my recommendation, and hopefully that would prevent any flooding that would be caused by something that could be put up like a wall, and it would also help with erosion if you put the overflow swell all the way into the pond. But finding those sags, very critical when you're reviewing the storm drain system. One of the most important things you can do is finding those sag points and then looking at the plans and determining what happens at those sag points. Is there going to be flooding here? Determine how much area goes to that sag point in the event that the storm drain system has failed, and then what happens.